Right, Bismillahirrahmanirrahim. Welcome to the fourth lecture, I believe. आप थे पिछले लेक्चर में?
जी
अच्छा. What did we discuss? कुछ याद है?
सर वो काउंटिंग और उसकी प्रोबेबिलिटी मैथ फंक्शन और
Right. So, जो the thing we did with probability mass function, cumulative distribution function, what was the idea? Basically, so the first module was assigning probabilities, some methods of doing that, right? Count the sets if they are equally likely. Then we said, okay, let's collect the probabilities, right, in some functions or in some containers, formulas. So we decided that we will talk about 5 different important ways of collecting probabilities, and they represent their own interpretation. So we will one thing we said, okay, let's say we are talking about a random variable that is discrete. याद है हमने define किया था what's a random variable? Let's say there is a variable x. Yes. So what makes it a random variable? आपने इससे पहले भी you have studied variables x plus y equals 4, for example. Yes. But what makes this variable random? It takes its value based on a random event. Yes. So इसकी value that has to come from some random occurring. Random means something where you don't have all the formulas, physics, maths, all that collected. There is some uncertainty there, right? So if it takes its values, and it has to take numeric values, right? Then we said, okay, if it takes a discrete set of values, we will call it a discrete random variable. Okay? If it takes a continuous set of values, we will call it a continuous random variable. So, for example, for a discrete random variable, it may be able to take, let's say, x1, x2, x3. Maybe it takes 4 values. Okay, so it takes one of these 4 values. For the case of rolling a die, how many values does x take? 6, right? So in this case, maybe it could be up to, in general, it could be up to xk. Yeah. So as long as the values are discrete. So we said, okay, one thing we may be interested in is saying, okay, what is the probability that x equals x, the small x, which could be one of these, right? So, and if it's not one of these, then we know that the probability will be 0. Yeah. But say probability x equals x. And we said, okay, for discrete cases, we will collect it in the probability mass function, right? We defined it like this. Yeah. So we said that the probability x equals x, that x takes this value, will be written as f small x, and we call it the probability mass function, and we did that in detail last time. Then we said, often we are not just interested in a fixed value. So keep in mind, I am still talking about discrete random variables. For continuous case, this will have to change. We will see that today. Yeah. But for discrete case, what do we have? We're going to say, okay, we're going to save these probabilities in a function, and we will call that fx. So what would fx1 mean in this case? That probability that the random variable x takes the value x1. Yes? So then we said, often we are interested not just in one value, we're interested in a range of values. Let's say this thing. So what is this saying? Let's say the number of mobiles the next student coming in to the classroom has. That's a random variable. Yes. Why is it a random variable? It takes numeric values. Student can have 0 mobiles, 1, 2, 3, so on. Yeah. Takes numeric values. and it takes the numeric values based on a random occurrence. I cannot predict जो आएगा next उसके पास एक. I can guess most likely they have one, yeah, but they may not have any, or they may have two. So what's the probability that the next student coming in has two mobiles? That will be x equals x, and we put it in probability mass function. I'm summarizing what we did last time. What's the probability that the next student coming in has two or fewer mobiles? One or fewer mobiles. And for that we said, okay, we will define a new function that we will call capital F of x. And what's that? Cumulative. Cumulate करना क्या होता है? Accumulate जो होता है to collect. Yes. Why is it cumulative? Because it's saying, give me all the probabilities of all the values less or equal to x. Yes. So if we assume that these are in order, so x1, x2, x3, x1 is smaller than x2 and x3, x4, then if I am talking about f of x3, yes, if I assume that x1 is less or equal to x2, less or equal to x3, actually it shouldn't be equal in this case, so it is 4. fx3, what am I saying? Probability that this random variable takes a value x3 or less. Yes, and that from now on, for this kind of range, we will call that the cumulative distribution function. Yeah, and we also saw that actually this is more or less redundant, because you can write it in terms of this guy. What was it? So how do we write the cumulative distribution function in terms of the probability mass function? We saw that you have to sum these for all values less or equal to x, right? So we saw that in detail last time. It was, in this case, we would be talking about fx1 plus fx2 plus fx3. Agreed? Why is that? We are saying, what's the probability that x takes the value, a value less or equal to some particular x. Now if you're talking about, in this case, if you're talking about x3, this is what it would look like, right? What's the probability that it takes less or equal to x3? Well, it can either take x1 or x2 or x3. So we sum that up. And in general, we were able to write this thing as what? So we were able to write it as saying fx is in fact just a summation of the small f x, right? And here we can put an xi less or equal to x. That's just a mathematical summarization of what I explained here. The cumulative distribution function will be the sum of the probability mass functions up to that point, and we saw that last time. Now the next one we wanted to cover, and I mentioned briefly, was when we talk about, previously we had done this, we had talked about probability, let's say we had talked about probability of one event, yes, but then we went to combined events, like we said, okay, what's the probability that A and B occur at the same time, right? So here we may be interested in talking about two random variables. What's the probability that the next student coming in has two mobiles and one pen? Yeah. So let's store the number of mobiles the next student has in a random variable, call it x. Yes, and let's save the number of mobiles the next number of pens the next student has in another random variable. Let's call that y. They are both random variables. Why? They take numeric values, yes, and they're based on random event, some uncertain event, and they're both discrete, right? Mobiles can be 0, 1, 2, pens can be 0, 1, 2, 3, so on. So in that case, we may be interested in saying, okay, what's the probability that x takes the value x. If this is number of mobiles, we are saying what's the probability that x takes value any x, 0, 1, 2, 3 from the set of possibilities. And sometimes we just summarize the and with a comma. Okay, we just write it like that. So that means it's an and y takes a value small y. Now it's up to you, depending on how you define it. You could be asking what's the probability that the number of mobiles next student has is 2, number of pens has is 3, 2. You can put any values. Why do we stick to variables? Because it's general, yeah. But you can imagine that in reality you will have to put some variables there to answer the questions. Now this will lead us to the joint probability distribution function. Okay, JPDF, and we have, again, like those guys, we have a name for it or a symbol for it. It is fxy with 2 parameters. Okay, this guy collects the joint probability, and this is where we stopped last time, so I will come back to this again now very quickly. And of course after that there are 2 more that we want to discuss, and those are, this is probability mass function, probability x equals x. This is cumulative distribution function. Probability x takes on a value less, it's for a range, yeah. This is joint for 2. You may be thinking, okay, why 2? There should be 3 also. Yeah, it is actually there, but for this course we stay up to 2 variables mostly. Then if you remember, we had another thing in events. What was that? Probability A given B. Yeah, the conditional. Yes. So similarly here, we would be interested in asking this question, and we will have another distribution function for that. We will call that the conditional distribution function, and then the marginal will come. So these are 5, and I covered 2 of these in details last time, so I will see if we can start. So if you remember this, we said, okay, we want to assign discrete probabilities. This is what we will do. We discuss the conditions. I gave you the example. Let's say we're playing a game. There is a bag with 3 balls in it. You randomly select 1 ball, take it out. The number written on that ball that you just took out, if we put that in a variable, that variable is a random variable now. Yes, because it took its value based on a random event. Yeah. And is it discrete or continuous, that random variable? It is discrete. It only has 3 possible values in this case. Yes, 1, 2 or 3. It would be very strange because bag mein aap hard dale and ball comes out 8. Right? With this experiment, yeah, something would be very scary. Anyway, so the probability mass function, you could write it in a table or just represent it as you like. This will come in handy when we work. From here on, mostly for the rest of the course, we will mostly skip the P notations. We will go to the functions, the small f, the capital F, because they are more efficient in representing things mathematically. Okay? So this is a transition from there. As I said, sometimes we are interested in the range. So as I said, these things I have already discussed. In that case, the cumulative distribution comes in. The word cumulative means to accumulate, collect the probabilities in a range, and this was the formulation. By definition, this is what it represents, and by formulation you can relate it to the small f also. So this relation puts together PMF with CDF, the cumulative distribution function. And we saw that the cumulative distribution function was non-decreasing I discussed that last time. You can see the video, it's uploaded. Yeah, we discussed this also, so let's move on. And you help me find this one. Remember the last one of the last things we did was okay, what's the probability that x is less or equal to x? ये table आपको समझ आ रहा है? What's it showing? So the random variable capital X can take only 3 values. Yes. Each one itself is equally likely. Yes. What's this saying? F of 1. Probability that the ball shows 1. That is 1 by 3. Yes. 3 balls, you could pick one randomly, of course, it should be 1 by 3. So, same here. But what about the cumulative? And as we said, what's going to happen now? So, and what would this mean? F1. Why 1? Because this is the row of 1. So, what will be capital F1? It would represent probability X shows a number less or equal to 1. What's that probability? 1 by 3? Because there are 3 balls written 1, 2, 3. So what's the probability that the ball you took out shows 1 or less? एक ही chance है ना? The ball, right? So it is 1 by 3 here, which is basically your F1. This guy, F of 1. Yeah. Then what's the probability that the number written is less or equal to 2? Now there are 2 chances. If 2 is written on the ball or 1 is written on both ways, your condition is satisfied. So you have to add both of them, and of course they are mutually exclusive, so you can just sum them up, F1 plus F2. What about this guy? You can already guess, it's F1 plus F2 plus F3. Now without calculating, what should this be? 1. Yes? So cumulative distribution function always approaches 1. It has to reach 1 and then stop. Why? Because by the end you are saying what's the probability that the number written on the ball is 3 or less. Well, that's all that is possible. It is going to be 3 or less, right? Okay, the numbers written are 1, 2 or 3. So this was 1 by 3. This is 2 by 3, and this is 3 by 3, 1. Yeah? And this is the summation notation. Right, so yeah, we saw that. We will satisfy the conditions. And then I said, remember I talked about being interested in ranges. Yes? We said, okay, we are interested in probability X is less or equal to X. Yes? But you may say, okay, I might be interested in probability X is greater or equal to X. Or probability X is between some X1 and X2. Right? These are also ranges. The thing is, we only define a function, the cumulative function for this case, and this can be reused for all of those. Okay? So you can see for probability X greater than A, it's actually 1 minus FA. Okay? You can try to see why that is very easy to understand. But notice all of those ranges that I just mentioned, X between 2 values, can be calculated based on the cumulative distribution function. And the cumulative can be calculated based on the small f, the PMF, yes, probability mass function. So it's not restrictive when I say that the cumulative distribution function represents this. Actually, it then can represent any range. Okay, so I'll leave that to you to practice and go through. Okay, this is where we stopped last time. Probability of 2 events or 2 random variables taking their values together. So in that case, we have the joint probability distribution. So first one, kya thi? Probability mass function. Another name for that is probability distribution function, right? Dono naam use hote hain. Discrete case. We will come to continuous later. Thoda sa wahan things will be different. Little bit. Okay. This is all for discrete case so far. Probability mass function, cumulative distribution function. Now this is the third one, joint probability distribution. All it's saying is, okay, we will put it in a function just like we did for the single variable case. Now the three conditions it must satisfy, of course, as before, since it's collecting probabilities, probabilities cannot be negative. Yes. So along with that, what's this saying? Can somebody tell me? I'll have to hide this. I've written the answer here. What is this saying?
Total probability 1 on J and Z.
Total. Why? What is the total? What is this? All x, all y. What is that? Saying, well, they have to take sum of. If you sum over all the possible values of x and all the possible values of y, then the probability should be 1, right? Otherwise, something is wrong in your definition. And this is just the definition. So let's check the joint probability on our example. We'll have to, of course, bring in another variable now. Yeah. So we're going to change the experiment a little bit. Okay. Remember when we talked about in the first or second lecture about assigning probabilities? There were 5 steps. याद है? Lecture में से देखा right? 5 steps in assigned probability. Define the experiment. Define the outcome of interest. Define your universal set. Then assign the probabilities. What's the fifth? Check that they make sense, which was the axioms of probability. कि negative तो नहीं assign करनी, कि positive 1 से ऊपर तो नहीं आ गई total, right? Those checks. Yeah. So here I'll change the experiment now. So since I've changed the experiment, we have to now go through. Okay, what's the event of interest? What's the sample space then? What is the experiment now? You have a bag with 3 balls. You draw 2 balls, one by one at random. Okay, you don't replace. Yeah, so you take out one ball, put it there, and you take out another ball. Okay, so what are the possible values? X represents the number written on the first ball. Y represents the number written on the second ball. Remember, you did not put the first ball back. Okay, replacement नहीं है. So what are the possible values of x? पहली ball पे क्या क्या लिखा उसको? 1, 2, 3. Yes. What about the second one? Agreed or some different answer? Same. Yeah.
1, 2, 3.
1, 2, 3. Because you don't know पहली पे क्या निकला, so it could still be 1, 2, 3. Yeah. Okay. Sample space क्या है? Pairs है ना? Pairs बनेंगे. Yeah. Sample space means in this case, if they're just taking one ball out, it will be like x. The sample space is 1, 2, 3. But what's the sample space in this case? क्या possibilities है? पहली ball पे क्या लिखा हो सकता है? पहली पे 1 लिखा हो सकता है. दूसरी पे क्या लिखा हो सकता है? 1 नहीं हो सकता है ना? क्या हमने वापस नहीं रखी? That's out of the world of possibilities. Yes, that's what sample space is all about. It's the world of possibilities where in your experiment, not the whole world, right? जो आपका experiment है उसके अंदर क्या possible? So 1, 2, that's one possibility. Another one?
1, 3, 4.
1, 3, good. 2, 1. 2, 2 नहीं हो सकता यार. 2, 3. 3, 2. Now in our case 2, 3 and 3, 2 are two different things. Yes, because the first is an ordered pair. Yeah. So and
3, 1.
3, 1. कितनी possibilities है? 6. Are they equally likely? There is no reason to think they are not, right? They should be equally likely. कोई वजह नहीं है कि 3, 1 निकले और 1, 3 ना निकले. Yeah. We know 1, 1 is impossible. 2, 2 is impossible. 3, 3 is impossible. Other than that, these 6 possibilities are equally likely. This is the sample space now for this experiment. Yeah. So yeah. So good. We got that. So now we will define the probabilities, the individual probabilities of x as gx. F हम use नहीं कर रहे क्योंकि we want to use it These are two different variables now, so we're just changing the notation. But this is the probability mass function of x. This is the probability mass function of y. Okay, you could write it like this also. You could write those as fx x and fy y, but it's very common to use a different notation, so it's fine. Anyway, this is gx and this is hy. Okay, so we define those, and then we see. Now can somebody help me put these in here? We want to put in the joint probability densities here. Basically, we want to write here F11. Yeah. What would that mean, by the way? What would F11 mean? So here we will have F11. Why is it 1 1 1 1? Yeah, easy to see. So what would F11 mean in this case? जो example हम देख रहे हैं, drawing balls, yeah, from the back. What are you saying? Probability that the first ball has a 1 written on it and the second ball has a 1 written on it. What is that? We already know. It's 0. Yeah. Okay. What would this represent? F12. Probability that the first ball. I'm not interested in the actual answer, right? I want this to really sit in your minds when I read fxy. When you read fxy, what are you reading? Yes, you're reading probability. The first random variable takes the value small x, and the second random variable takes the value small y. That's why I'm emphasizing here. When you see f12, you're saying what's the probability that the x, because we call the first variable x, so I'm saying x takes 1, the first ball shows 1, second, what was it? Kitna hoga? 1 by 6. Why? 6 possibilities, all equally likely, so yeah, makes sense. And so on, yeah? So you can fill this, get used to this thing. Yeah. Yes? Makes sense? Now notice that this satisfies our conditions also. Remember, the joint probability distribution function has to satisfy this condition. It should never be negative. None of these are negative. Yes? It should sum to 1 if you cover all the possibilities of x and all the possibilities of y. Where do you cover all those possibilities? In this whole set. Yes? This table. If you sum these, what do you get? 1. There are 6 1 by 6s, so 1, yeah? And the last, of course, is the way we put the probability. Right. Now, we have been looking at probability, density, mass function for discrete so far, but it's drawn in continuous here, it's fine. The probability mass function or the density function that we'll see later is in 2D. Yeah? Along x-axis you have the values the random variable will take, and along y-axis it's the likelihood. Yeah? But now for joint distribution it becomes 3D. Why is that? Because now x will take its own values, yes? Y will take its own values, the first random variable, second. So the probabilities you write, they will have to show in the third dimension. Yes? It's like plotting this table. If you had to plot this table, how would you plot it? Well, you will need an x-axis showing 1, 2, 3. You will need a y-axis showing 1, 2, 3. And then these intensities at 1, 1, the value will have to be 0. Yes? At 1, 2, it will have to go up to 1 by 6, and then so on. Wherever it's 1 by 6, it will be 1 by 6, otherwise it will remain 0. Okay. So that's just an additional thing. So probability over an area, that's a useful formulation. We say that what's the probability, let's define an event A, that x is greater than 1 and y is less than 3. What's that saying? That the number written on the first ball is 2 or 3, and the number written on the second ball is 1 or 2. Yes, less and equal yes. Yeah. So if you define that area, then you can still calculate it from here using this formula or just common sense. Yeah, in this case, कौन सा part sum करेंगे to find this probability of A. Yeah, so you identify where you are. Yes, where is x greater than 1? You identify that part. Yes, then you identify where is y less than 3. The shaded parts, and this is where x is less than greater than 1. Yes, and this is where y is less than 3. Yeah, where is the overlap? दोनों होने चाहिए, joint है. Yes, so the red part is the overlapping part. That's what this formula is saying essentially. कोई इसमें magic नहीं है. Yeah, it's only saying, okay, find the overlapping part which defines the area A, the area or the region where both conditions are met. Yes, together they are met in this red part. ऐसा ही है ना? In this red part, all the possibilities where x takes a value greater than 1 and y takes a value less than 3. If you sum them, that would represent your probability of that region or that event. Right. Now the marginal is nothing special. This is the fourth one now. Probability mass function, cumulative distribution function, joint probability. Now the marginal. Marginal is basically just the probability mass function. Okay. The only reason we call it marginal is when we calculate it from a joint distribution. So there are situations where you will know the joint distributions, but you will not know the individual probability mass functions. You can still, in many cases, derive that one from the other. When you take a joint probability density function, so if you start with the joint probability density, that is fxy, and you extract from it just the probability mass function of x, which we sometimes call this, or we can call gx, just to emphasize that it's the way it's derived. Okay, it's going to be exactly the same as the mass function, nothing different. Only thing is that you derive it from this direction. Okay, so in that case you should know how to do that. So let's see how we will do it here. Marginal distribution of x. This is how you can get the marginal distributions. You sum fxy over all the possible values of y. Okay, and if you sum over all the possible values of x, you get the marginal distribution of y. Why does this make sense? I am saying this is the distribution of x. Yes, that capital X takes this value. Yeah. What we did was we said, okay, if you give me the joint distribution, if I sum it over all possible values of y, then I will get the probability of x. Yeah, why is that? Because of course for any given x, y has to take one of its values. Yeah? If you use all the values of y, then you have covered all the possibilities of y. So let's see that happening here. What's the probability that, let's say, if you want to derive your probability here, what's the probability that the first ball, this is showing you, this is showing you probability that the first ball shows 1. Okay, this is actually your probability mass function for the first random variable. Okay, so what's that probability? Previously you could have done in some ways, but in this case you don't have that, do you? हमने तो इसे start नहीं किया, right? But you can evaluate it if you know the joint distribution. Now in this experiment it is easier to define the joint. कर लिया था ना हमने, फौरन लिख ली थी, we wrote all the joint distribution. But the marginal or the mass distribution is a bit harder, so you can evaluate it from here. What do you do? What's the probability that the first ball takes the value 1? You say, okay, there are 3 cases. The first ball takes the value 1 and the second takes 1. That's one way this will happen, right? What's another way this will happen? That the first takes 1 and the second takes 2. So the third way, first ball takes value 1, second ball takes value 3. These are the only possibilities. इस रो में your condition is always satisfied, isn't it? You are only now interested in the first ball. Yeah? So you cover all the possibilities of the second ball, sum them up, and you get the possibility that you are looking for. What about the same thing for the second ball? If you want to say, okay, this is saying probability y equals 1. What's that? The second ball takes the value 1. How many ways are there where the second ball takes the value 1? Either to nahi hai, none of these satisfy that. Right? What satisfies this? The first column. Yes? So you are summing over all the values of the second ball. Okay? So just think about it some more and you will understand that this formulation that we just did, it makes a lot of sense. यही हमने किया ना? Okay, when we summed over all possible values of one variable. So to find the marginal of the first variable, simply do this. Take the joint and sum over all the possible values of the other variable. Yeah? अगर y की चाहिए तो x पे sum करो. Yeah? अगर x की चाहिए तो y पे sum करो. Okay? And if you go through this example at home again, try to see what's really happening. It will start making more sense. थोड़ी सी practice चाहिए होगी. Right. So now to the fifth one. होगी ना 4. What was the probability mass function? The probability x equals x. Cumulative distribution function, probability x less or equal to x. Yes. Joint probability, that probability x equals x and y equals y. Marginal, when you get the first one, the PMF from the joint by summing over the other variable. You call it the marginal. Fifth one of the most important ones, the conditional. Just like, remember, we have probability A given B, so we want to store that somewhere also. So for that we have this guy, and since we have already discussed the events of conditional probability in detail, we will just use this to show. For example, you might be interested GPA 5. This was written for another country, so I have to change it. यहाँ पे 4 है ना, 4 है, yes. So in that case, of course, you can say GPA 5 is impossible here. But anyway, what is the probability a student will get GPA 5 in this semester, given that his or her CGPA in previous semester is 4.5? That's one way of looking at conditional things. Yes, we're just giving an example that you might be interested in that. So then you are saying, okay, let X be the GPA student will get in this semester, the running semester. Yeah, and Y is GPA now, yeah, 4.5. So in that case, okay, what's the value of one given the other? And in such situations, we need the conditional probability. Let's see if I have that written here. First, let me define that. So that we will do like this. It's probability x given y. Yes? Okay. And we will write it to make it even more clear now in terms of numbers. We say probability x takes the value small x given that y takes the value small y. Okay? Random variables. Same thing. And this thing we will define now as f x given y. That's it. Yeah. What is this representing? F small x given small y. What is that? Probability that the first variable or this variable x takes the value small x given, when you are given this information, that the second random variable took this value small y. Okay, so that's the definition. But then, if you remember, even for conditional probability, we had something. What was that? It linked formula था ना हमारे पास, क्या था? In terms of joint probability x and y divided by probability of y. हमने a b में लिखा था, so same thing, variable. That was event. This variable doesn't matter. The formula remains same. So same thing you can do here. कैसे करेंगे? Replace the left side with this definition function. Yes, f x given y. यहाँ किससे replace करेंगे? From the functions that we just learned. Probabilities को replace करना है हमने functions. Yeah. So I already mentioned the left hand side can be replaced by f x given y. What about this thing? इसको किससे replace कर सकते हैं? You just learned that. Which one? Capital F, small f x, small f y, small f x comma y. कौन सा है? Joint. ये joint है. Small f x y. Yes. Right. So if I don't run out of space, it's basically f x given y equals, this thing is small f x y, the joint distribution, divided by probability of y. Yeah, since we are already using f, what did we call this guy when you derive it from there? Marginal. Yeah, so it was h y. So we can see that now in the next slide. This is what's going to happen. Probability, this was I was writing f x given y is f x y divided by h y. Probability of y alone. Yeah. Here f y given x is f x y divided by dx, and of course this is a requirement. The denominator should not be 0, and we discussed that in the conditional probability case already. So let's look at this now again. In this case, just like before, you draw these, that's fine, and we had already done these. But now it's a bit different. What is it saying now? It's now the conditional probability. Can somebody tell me what is now the meaning of f1 given 1 in terms of this experiment? Kya hoga? It's the same experiment. 3 balls in the bag. You take one out, then you take another out. Yes? The first variable represents the number written on the first ball. Second represents the number written on the second ball. Yeah? So, kya tha? This is probability. And in this case, I think we have changed it because the second ball has to come first. In this case, yeah, because we want to say, okay, y is here, x is here. We shifted their positions. So we are saying, what's the probability? This is fy. This is fy given x. Second ball, first ball. So probability that the second ball shows a 1, given that the first ball already showing a 1. What's that? 0. Right? Because repetition is not 1. What about this one? is saying probability that the second ball shows a 1 given that the first one had a 2. क्या होगी? लास्ट टाइम आपने क्या निकाली थी वो f1 2 आपने निकाली थी लास्ट टाइम f1 2 was 1 by 6. What was that saying? Probability that the first ball shows a 1 and the second shows a 2. That was 1 by 6. This is different, isn't it? क्या different है इसमें? Here, we both were uncertain. In this case, you have been told that the first ball showed a 2. Now, what's the probability that the second ball will have a 1? Go. ये तो easy case है, ये तो 0 है. What about this one? Previously you had 1 by 6, but now it's a conditional thing. कैसे करेंगे? ऊपर से देखेंगे. What is it saying? Probability. Again, I will write it. I want you to actually really get it clear in your mind what's going on. This is saying probability y equals 1 given that x equals 2. ये y है ना, ये x है, ठीक है? Probability second ball shows 1 given that the first was showing 2. ठीक? अब यहाँ possibilities देखें. Look at the possibilities. Yes? Which of these satisfy at least this condition? Now you know this has happened, yeah? So your universal set should become smaller in this case. Yes? So which of these have the second, the first ball showing 2?
First column में second.
हाँ वो तो इधर से यहाँ पे. Third and fourth. Yes? These are the only cases where this is satisfied. Yes? Now you are told that the first ball showed a 2. So you already know that now the second ball, since the first ball showed a 2, these cannot have happened, these cannot have happened. Yes? Only one of these two could have happened. Now you want to answer what's the probability that y takes the value 1. So the second ball will take either 1 or 3 with equal probabilities, equally likely. So what's the answer then? 1 by 2. Right? 50%. As soon as I tell you that the first ball took the value 2, your sample space shrinks. It's not this anymore. ये तो impossible हो गया. ये भी impossible हो गया. Only 2 possibilities left. Yes? And I'm asking you about one of them. Both are equally likely. दो में से एक चांस एक ने होना है. दोनों को भी बराबर चांस है तो 50-50 देने पड़ेंगे आपको. There is nothing else to do. Yes? समझ आइए? Okay? So now have me find the third one. First tell me what it means. Step by step. What? Read it. What is it saying?
पहले बॉल जो है वो 3 और सेकंड बॉल.
ठीक है. पहली बॉल पे गिवन है आपको. मैंने I've told you now that the second ball has a 3 written on it. Yes? I've told you. Then what's the probability that the first ball has 3 written on it. So what's the probability that the second has a 1 written on it? So अब वहाँ कौन सा possibility है? आखिरी दो, right? These two now. So again, I'm asking for one of them. 50-50. 1 by 2. Yes? So you can guess actually it will be 0, 0, 1 by 2, 1 by 2. Yeah? Okay? So keep in mind that joint and conditional are very different things. आपने joint निकाला था ना 1 by 6. But F1 and 2 is 1 by 6. F1 given to is different. Yes? They could be same. When they come out to be same, we say that the variables are independent. We discussed that when we discussed the events. So I'll come to that also. So anyway, let's put on the pen here. this is done. And statistical independence, as we saw, the two random variables. Yeah. So, if you remember, for two events, we said if the probability of A given B, probability of A given B equals probability of A, then we say the events A and B are independent. We discussed that in detail before. Now in this case again it's the same thing. Statistical independence, you could prove it from here. Yes? Or we said there was another way to prove it, which is actually derived from here. I did that last time, but I'll just write it. Is that the joint probabilities if they are separable. Okay. Now I want to write this condition again in terms of the functions we just learned. It's very easy to do that. Yeah. What's the function we learned for conditional probability? The conditional distribution function. So this will be f x given y. Yes. If that equals what? Probability of the first one, which we were represented as gx. Yes. How would you write the second condition? Second way. You don't have to satisfy one. If one is satisfied, the other is satisfied. So either of these tests proves that the variables are independent. So how do you write this? This will use fx comma y, the joint distribution function equals, okay, we will use g and h, gx and hy. It equals their individual probability, the product of their individual probabilities. Okay, so we have just rewritten what we already did in detail for events. We have now written that as functions of random variables. Okay, so this is what's happening now. If fx given y is gx, or fy given x is hy, or the fxy are separable like this, in general this is not true. Okay? It's only if it is true, then the events are, or the variables are independent. So in our example, जो हमारी है वो 3 balls वाली, yes, are x and y independent? What's your guess? Independent. So first, logically think about it. If you know what's written on the first ball, okay, does that change the probability of what's written on the second ball? It does, yes, because that tells us, if I say the first ball has a 1 written on it, all of a sudden now the second ball can't have 1 written on it. Okay? Before I told you that, अगर मैं बताने से पहले पूछूं आपसे तो second ball can have 1 written on it, आपको नहीं पता. But once I tell you that the first ball has a 1 written on it, the second cannot have a, तो उसने change तो कर दी ना उसकी probability, right? So they are actually very dependent, and you can check that here from the test. As we said, if probability of one given the other is separable or not. So for example here you can check that fxy is not the product of separate ones, and that the probability of the event actually changes. So we have done that for variables, and I'll let you take some questions before I go to the continuous case for what we have discussed. Okay? Any questions so far? There's a lot to absorb, I know. It's a summer course. I have to go a bit faster. We'll discuss that afterwards. आपके हैं किधर? CR is here? Or no? Did he send you the my messages?
Yes.
Yeah. about starting to practice from the exercises, please. I will also hold some problem sessions, but it's good that you start working with these. Yeah, these are concepts, but then you have to log those concepts by practicing on numerical examples. Okay, and please, the way you do this, for every lecture, take 1 or 2 sheets, okay, and write the very summary, very crux of what's in there. Don't write the whole lecture. Don't copy the book. Yeah, crux kya hai? Equally likely, same probability. Mutually exclusive, cannot happen at the same time, means probability A and B equals 0. Just the crux. अगर एक lecture को आप summarize करें ना proper, सिर्फ crux. So even एक sheet पे भी आता है. I'm telling you 2 sheets, okay? Yeah. Then take those 2 sheets and read the problem in the book. Don't read the solution. Yes, read the problem, and then look at those sheets and try to solve the problem. Then try again, and after 3rd try, if you still don't get it, then look at the solution, and then ask yourself, what's in the solution that was missing in my understanding? Development में फर्क था, शुरू में आएगी मुश्किल आएगी, yeah? So even with the knowledge, approach could be a bit incorrect, so you will need to practice that. Approach, practice ही ठीक होगी, but you also need the right knowledge. Yeah? And so please do that. Many of you, what you do is, I don't know, you highlight on the books, or well, they are huge. You need your summary. When I was a student, for each of my courses, the whole course used to be around, without exaggeration, 10 to 15 sheets, summarized sheet. वो भरी हुई नहीं, bullet points only. Yeah, you practice those points, you understand those key concepts. Of course, उसकी फिर practice करनी होती है साथ. Yeah, then you are in good shape. If you don't extract that key information, if you think I will read what's highlighted, or I'll just click through the video very quickly and my mind will retain, नहीं होगा, सब कुछ mix हो जाएगा. Okay, so please help yourself with that. Right. So far we have been discussing collecting probabilities for discrete random variables. Now let's say, what's the height of the next student coming in? Is that a random variable? Yes. Yeah. Is it discrete? है या नहीं? वैसे by physics तो नहीं है ना? We could discretize it, but then you can work with discrete random variable. Let's basically most natural phenomena, temperature in a room, humidity, luminosity, distances, heights, time, in their very nature they are continuous. Yes. So if they are continuous, it helps us to also talk about, okay, how do we deal with that? Now, the distribution functions for continuous random variables, the concepts are very similar. Okay, the formulas even very similar, but there are 2 key differences. If you understand those 2 key differences between discrete random variables, distribution functions, and a continuous random variable, that's it. You will have no trouble. Whatever you learned here applies. Okay, but with 2 key differences. So I will talk about that. But before that, we have been talking about assigning probabilities to, like this example of drawing a ball or rolling a die. Yes, it's the easy cases. How do you assign probabilities to heights of people coming in? कैसे कर सकते हैं? कोई idea? So what's the probability that next person coming in has a height less than 5'10", or in centimeters 178 centimeters? Yeah. Rolling a die makes sense. The 6 possibilities are equally likely, and the physics seems like there's no reason one side should show up more often. So 1/6 each. Yeah, makes sense. But either physics लगाना बहुत मुश्किल है. You'll have to find, I don't know, we have in इस तरह के formula. What should human heights be? What's the genetics? कितनी होनी चाहिए? Yeah? It's very hard to do it from फिजिक्स और बायोलॉजी, फिर क्या करते हैं? Statistics. This course is probability and the statistics will inform the probability area. Yeah, it will help you assign the probability. What's the statistics? कैसे guess कर सकते हैं height of the next person और probabilities तो बता सकते हैं कैसे? Well, let's see that. Close this and go to the board. Now for the case of showing a die, it's very clear. 1, 2, 3, 4, 5, 6. 6 possibilities हैं. Each one will be 1 by 6. Yes. This is the case of rolling a die. Yeah, easy to tell. In discrete case, there could be harder cases also, but like what's the probability the student has 2 mobiles, 1 mobile? Okay, now it's hard. Yeah. That is where statistics comes in. So also for the continuous case, you could have cases where the physics, the biology will help you, but in many cases it will become too hard to do that, or we may not even have the knowledge. Then we go to statistics. So height of the next student coming in, one way is you go to Pakistan's government census data, you ask them, okay, your census data, maybe पूरी आवाम का नहीं होगा उनके पास, but let's say they have for 80% of the population, you ask them, okay, what are the heights of the adult population? That's your statistics. Yes, and then you can see, okay, if you plot those heights against some distance, you have centimeter में, let's say, right? I am 178 centimeters. Yeah, you are close to that, most of you, right? उसी range में. So these are the heights in, let's say, centimeters. Okay, and when you get that data from the government, somehow you find that, okay, most people, अगर आप लोगों की heights को लिखते हैं या density उनकी बनाते हैं, you find that, okay, most people are in some adults, बच्चों की नहीं होती, medium height. पाकिस्तान में मेल्स की एवरेज हाइट इज 5'6", I think. Yes. In Sweden, the average male height was 5'10", and so I was average there. Every other person was taller than me. Here, I am mostly taller than many people here. Yeah. So changes with the country. Let's say this: we know someone from Pakistan is coming in, so we will take Pakistani data. Yeah. So you look at this, and then you realize, okay, most people are here, but then some are a bit shorter and very few are extremely short. Now already you can rule out the negative heights. Yes, हो नहीं सकती. Yeah. Same here, fewer people with these heights, very tall, and extremely tall, even more few. Yeah. फिर एक खास point पे जाके we know human heights stop. So what if I were to tally this, right? Some sort of density or likelihood of this. कि कितना यहाँ पे concentrated है. Yeah. So if I was to show that in a level, yeah. So this part will get a high level. Let's say this is a high level because lots of heights in this region. What about this part? Extremely short people, very few. Yes, shortest person in the world in Guinness book is like a few centimeters. So, but there are some, but the density here is very low. Very few people here. Same here, extremely tall people, very low. Then in the middle, as you go away from some middle, the sizes, the density is dropping. Yeah. So you could collect the data, yeah, and tally it, make some density for it. Okay, where are these? And that is one other way of doing or assigning probabilities. So far I've been mentioning the rolling a die, throwing a die, tossing a coin, those kind of examples. But realistic examples are not those, yeah? They are more like, okay, what will probably next student has 3 mobiles. उसमें तो आप नहीं कहते कि 1/3 चांस है कि उसके पास 0 होगा 1/3. We know that most likely that person has 1 mobile, yes? But फिर 2 mobiles का क्या chance है? There is no mathematics or physics that will help me answer that. Only thing I can do is try to collect statistics. PTA से पूछें कितने मोबाइल आपके registered हैं, let's say. Try to guess from there. So I just want to mention this here because this is one other way of assigning probabilities, which is based on statistical data. And then we often try to see, okay, does it look like a nice function? What function does it look like? And we will see those functions later. But going from there to the actual question that I was asking or talk to you about is, okay, how do we assign or not assign, how do we represent the distribution functions of a continuous random variable? So as we did for the discrete case, what did we do? We said, okay, probability that x takes the value 4, we represented it as f4, right? This is our probability mass function. And the probability that x takes a general value x, we call that f small x, probability mass function. Now the problem with continuous cases, like the height of the student, is this. When a random variable is continuous in its range of possibilities, कितनी values possible है इसकी? Continuous है, ठीक है? Height, let's say, it's continuous. To इस range में भी है, but within that range it's a continuous value. So कितनी values possible होती हैं continuous? Uncountably infinite होता है, right? You could have, if you look at how many points are there between 3 and 2, 2 and 3, infinite, uncountably infinite. Because there is 2.1, there is 2.11111, there is 2.11112. It's just crazy, yeah? So any continuous range always have infinite, uncountably infinite number of values, right? तो फिर उनमें से किसी एक के होने का चांस क्या होगा? किसी एक का एग्जैक्ट, किसी की हाइट 2.111111 whole or 2.111112 now, क्या होगा? Guess कर सकते? 0. That is one key difference between discrete and continuous. For discrete, it makes sense to talk about probability x equals x. Okay, that x takes the value whatever you want from among the discrete set. For continuous, we know that that probability is going to be 0 for a given value. Yeah. So that means we cannot define this thing as fx because it will always be 0. कोई फायदा नहीं होगा इसका. That's one thing. Now I'll come to the second one, but you may wonder, okay, then what do we do? Yes. So the thing is, it still does not stop us from saying, okay, what's the possibility that this height of the next person is 178.01 to 178.02. Yes, we can still ask that question. Range की बात हम कर सकते हैं, उसके अंदर भी infinite values हैं. Yes, so in reality we are often interested in talking about ranges, and for continuous random variables, what we can do is talk about, okay, what's the range? So let's see here for a particular random variable, I might be saying, okay, what's the probability that the random variable x takes the value between 170 and let's say 170.001. Okay, this we could talk about. But you cannot ask what's the probability that x equals 170, because I know that will be 0. Okay. You can make this very small. And in general, you can say, okay, the probability x is between A and B, that is the case. Or you could talk about other ranges, like what's the probability that x is, let's say, less or equal to small x. Yeah. So that is what we will do today. Let me take a quick look at how we will do it. Right, so what we will do now is we will define a function for continuous random variables. We will call it fx. Okay, that fx will not represent probability x equals x. Okay, we already established that, because that will make no sense. This will always be 0. Then what kind of a function can we define which behaves like the probability function and can help us get the cumulative, the joint, the conditional without really changing everything too much? And that's where the concept of relative likelihood comes in. Okay, so this is what it does. Basically, we are often interested in saying, okay, what are the relative chances of something happening? So let's see that here. Let's say I have a continuous random variable over 0 to 1. So assume there is a random variable that is continuous, and it takes a value between 0 and 1, and all the values are equally likely. Okay, so it can take all the values with equal probability. Yeah? Then I can draw its relative likelihood like this. If this is relative likelihood, it's saying what's the chance that this variable takes the probability, takes one value here, this value. I'm not saying it's that the probability that it takes this particular value is alpha. Okay, so first let's read this. It's saying probability, or f, if I call this fx and this is x, f 0.5 is what? Alpha. Yes. What is f 0.6? It is also alpha, isn't it? Yeah. Now for continuous random variable, this is not saying that this is the probability x equals 0.5, because we know that has to be 0. All it's saying is that these two are equally likely. Why is it saying that? Because it assigned them the same value. Yes. What is the possibility that the guy takes the value 0.9? The relative chances of that happening are again alpha. Okay, so this relative likelihood is going to help us define this. Let's say there was another case where, let's say, beyond a value k, it took values alpha and 2 alpha. Okay, so let's say this is 0.7. In this case, what are we saying? If we write f of 0.5 is alpha and f of 0.8 is 2 alpha, what is this saying? It's saying that the chances of taking this value, a value above k, is twice as much as this thing. Okay, so basically, maybe the concept of relative likelihood may be a bit hard for you to grasp, but essentially this is what happens. We say, okay, we will still define a function for the continuous random variable, but we will keep in mind that it does not mean, when it gives you a value, It's not saying that the probability x equals 0.5 is alpha. It's not saying that. Okay, it's only showing you what are the relative chances compared to other values. That's it. Okay, why is that helpful? Well, we will see now that actually this can help us resolve a lot of our issues. For example, in this case, if I have this, let's say there is 0.5 here, can somebody tell me what's the probability that x, let's say, is between 0.5 and 1? This case, if this is fx, what's the probability that the random variable x takes the value between 0.5 and 1? Sorry? 50%? पहले में. So, equal chances of being here, yes, and equal chances of being here. 50% chance that it will take a value greater than 0.5. Now, we will see that as basically, if I integrate from 0.5 to 1, fx dx, that is the area under this distribution here. Yes. So essentially what we will do from now on is this. We'll say, okay, we are going to define a density function that spreads the relative likelihood over a continuous range, and instead of calling it mass function, we will call it density function, and it can help us find probabilities in different ranges. Okay, so probability that x is between 0.5 and 1 basically should be represented by the area there. So then if you want to find the probability in any given area between A and B, how can you do that? From here, basically probability that x is greater than A and less than B, that is, it is in this some range, let's say A is here and B is here, so you're talking about this range, you take that area. So it will be A to B fx dx. Okay, and this will help us define something useful on, let's say, let's write that for the cumulative one. So I will write the discrete case and the continuous case. Yeah, so you will see that. Let's say we have the discrete case where I have some random variable taking 5 different values, 1, 2, 3, 4, 5 with different probabilities. This is the discrete case. For a continuous case, I may have, let's say, some sort of a continuous distribution. It could be uniform, it could have some other shape, but this is a discrete random variable, this one is a continuous random variable. This axis represents the probability mass function. This axis, the y-axis here, represents the probability density function. The only difference now is that mass has been replaced by density, because now you are spreading it over a continuous range, so density makes more sense. Now, in this case, what's the probability that x, let's say, is less or equal to 4? What was that? It's f1 plus f2 plus f3 plus f4 positive. Yes, for the discrete case we have already discussed that. So in general it would make sense to say that the probability x is less or equal to small x is summation fxi. I is xi less or equal to x. This we already did, yeah? And what was the name we gave to this thing? The cumulative distribution, right? F, capital F of x. This is the discrete case we already did in detail. Now we will replicate this here, where we will say, okay, let's say there is a the 4 is here, let's say. Then what's the probability that x is less or equal to 4 in this case? Now you will have it, what is that, minus, in this case it's 0 to 4, so you integrate over this area fx dx. Similarities nazar aa rahi hain? This was summation up to 4 from the left wherever it starts. If it starts at minus infinity, that's fine, you have to sum from wherever it is. Here it started at 0, so we had this thing. This is a continuous function, so you need a continuous sum. What's a continuous sum? Integral. Yes, वही होता है ना, it's just adding continuously. This was a proper sum, discrete sum. Yeah. So the two behave very similarly. This is the second difference. The first difference was, as I said, in the discrete case, you could always say that this equals probability x equals x. In the continuous case, you cannot say that. Okay. This does not represent that. That's the first difference. It's a conceptual difference. Okay. Second difference is that summations are replaced by integrals. Okay. You go from discrete to continuous. You go from summations to integrals. And if there are any differences, they will be replaced by differentials, derivatives. Yeah. So now, what can we write this? What is the general formulation we can give this thing for the continuous case? General क्या लिख सकते हैं? Just like we wrote general here. Yeah. Probability x less or equal to x was this thing. So इसका कोई बता सकता है क्या होगा? Sorry. A B है 0 to x. Yeah. So you integrate 0 to whatever x you want. Here I had it 4. Yeah. Can we make it even more general? Yes, we can. In this case, we knew that x below 0 wasn't there. But to make it very general, we could actually say probability for any continuous random variable being less or equal to some x, we could say it's minus infinity to x. If it happens to be 0 there, okay, that part will disappear. Yeah. But this now, this formula replaces this one. And what should we call this? Like before now, we will call it the cumulative distribution function. Cumulative, cumulative. What's the difference? In the discrete case, the cumulative comes as a sum, right? In the continuous case, the cumulative comes as a continuous sum, meaning integral, the area under the curve from here. This is also in a way collecting these up to 4. So you are actually summing these, aren't you? 1, 2, 3, 4. You sum them. Yes. So area under this up to 4. You are just finding this area. Now, the beauty of this whole exercise is this. Once you understand this difference and the difference that summation will be replaced by integrals, everything else, हमने 5 पढ़ी थी ना, कौन सी थी? Mass, function, probability mass function, cumulative distribution function, joint, marginal and conditional. Now, if you understand this difference between the probability mass function and this one we call probability density function, yeah, that's the only difference. After that they become the same. Cumulative का formula भी वही रहेगा. Whatever cumulative formula was, it's still the same with integral summation replaced by integral. The formulas for the definitions for marginal, conditional and joints will also remain the same. Okay. The only thing is wherever you had summations, now you will have integrals. That's it. Okay. So that simplifies our work, and we can basically work with both density functions and distribution functions. So any questions so far? I know this is the idea of going from discrete to continuous, bit confusing at start, but अगर इस summary को आप ध्यान में रखें ना जो मैंने यहाँ लिखी है, so it won't be too hard to understand. Okay. The only conceptual difference is here. That's one thing. Mathematical difference is here. Summations replaced by integrals. Okay. Otherwise, the remaining concepts. What's the meaning of the cumulative? Look, the meaning of the cumulative is exactly the same. Here it was saying probability x is less or equal to x. Here it's also saying that. It's only the meaning of the first function that's changed. Okay, but by smartly redefining the first function as a density or a relative likelihood, we are able to copy the discrete case exactly with summation replaced by integrals. That's it. कोई और फर्क नहीं पड़ता. Okay. So there is a next topic, but maybe I should not start that now. कितने बजे खत्म plan करेंगे? 40. So we could maybe discuss some other stuff. I'll just mention that after this we go to the third module in the next lecture. Okay. So what was the first module? Assigning probability, and in that we saw experiment, sample space, all those things. Yes, events, equally likely, mutually exclusive. We saw four important probabilities: joint, conditional, posterior, total. Yeah. Then we went to the second module where we collected the probabilities in functions. Yes, and there we saw the probability mass function, cumulative distribution function, joint, distribution, conditional, and marginal. And then we repeated that for the continuous case, which we just start. The rest is similar. The third module is about extracting key information from the distribution functions, from the density functions. So now fx, whether it's the PDF or the PMF, अब हम ऐसे ही लिखा करेंगे. आपने खुद याद ज़हन से रखना है कि if your variable is continuous, we are talking about PDF, probability density function. If your variable is discrete, we are talking about PMF, probability mass function. But how do we extract key information from this? Because this whole probability collection turns out to be too much information. Okay, so that will bring us to the concept of moments. Okay, so now आपने moments कहाँ सुना है? एक तो time वाले moments ना बोली moments सुना और physics में सुना क्या होता है? Moment of force, right? So there is a beam, there is a wedge under it. Yes, there are two weights put on two sides. Then the force each weight applies multiplies by the moment arm. Yes, वही होता है ना. Now something similar we will do here. We will try to extract some important information from these functions. Okay, and those informations we will call them the moments. Okay, some of the moments you already know, mean, variance, maybe you know covariance, or you've heard of this. Mean ka pata average ka, right? So they are actually extracted from here. So far you may have used them just as, like we say, okay, what's the average height? But in this course now, after this, you will see exactly where they come from. How do we extract them? From fx, yeah, or from the data, which will give fx, and then the moments, which will be mean, variance, covariance, correlation. That's the third module. Okay, so if you can link these and understand those, that would be good. So let's see. We will discuss a little bit about the Python assignment. So